A cylindrical iron roller has an external diameter of 150 centimeters and it's 5 centimeters thick. The length is 1.8 meters. Calculate using pi as 3.14 and given your answer to 2 decimal places, calculate the surface area of the curved surface in meters squared. So they want us to determine the surface area of the curved surface in meters squared. And so when they ask us for the curved surface, what they want is they don't want the surface area of the entire cylinder. They just want the surface area of the curved surface, right? Which is going to be this portion right now, right? This portion right now. The surface area of the curved surface. And so in order to do this, we're going to consider this slide. Notice that here is a cylinder. So we have the cylinder is made up of 2 circles, one at the top and one at the bottom, okay? And the area of these circles is given by pi r squared and pi r squared, right? But the question does not want us to determine, or they don't want us to consider this particular circle, neither this particular circle. They don't want us to determine what is the surface area of this circle, neither what is the surface area of this circle, right? They don't want to determine that. They just want the area of the curve section, right? So let me highlight that, the area of the surface area of the curve section. So they're referring to this particular part, right? The surface area of the curve section. And the surface area of the curve section is given by the area of this particular rectangle, because this is the rectangle that wraps around this cylinder, all right? And the formula for a rectangle is length times width. So we're going to take this 2 pi r, and we're going to multiply it by h. And so the area of the curved section, and so the surface area of the curved surface is 2 pi r h, all right? Now, if we wanted to figure out the surface area of the whole cylinder, then we would have added pi r squared and pi r squared. So it's going to be 2 pi r h plus 2 pi r squared. But we just want the surface area of the curved surface. So we're just going to use 2 pi r h. Okay. Okay, so what is pi? Pi is 3.14. What is the radius? The radius is 150 divided by 2, which is 75. And that's the truth, because if you look at this, the whole diameter is 150, right? That's the whole diameter, 150 centimeters. But we just want the radius, which is half of the diameter. So it's going to be 75 centimeters, all right? But let's convert 75 centimeters into meters. So 75 divided by 100 is equal to 0.75 meters. So the radius is equal to 0.75 meters. That's the radius expressed in meters. And then we have the height. The height is 1.8 meters, and that's this right now. And so in order for us to figure out the surface area of the curved surface, we say 2 pi RH, where pi is 3.14, R is 0.75 meters, and H is 1.8. When we multiply this, we get 8.478 meters squared. Again, 8.478 meters squared. And that's what they wanted to answer in meters squared, not centimeters, but meters squared. Okay, let's move on to the next part. It says, calculate using pi as 3.14 and given your answer to 2 decimal places, the volume of material used in making the ruler in meters cubed. So we want the volume, right? But we want the volume used in making the ruler in meters cubed. Now, how are we going to do this? Well, we don't want the volume of the entire cylinder. We just want the volume of the material used in making the ruler, okay? And it says here that a cylindrical iron ruler, right, has an external diameter of 150 centimeters and thickness of 5 centimeters. So in order to figure out the volume of the material used in making the ruler, what we're gonna do is we're gonna figure out what is the volume, right? What is the volume of this? So we're gonna figure what is the volume of the smaller cylinder. Like, what is the volume of this, right? So we're gonna figure what is the volume of this particular cylinder. Then once we figure out what is the volume of this, we're also gonna figure what is the volume of the big cylinder, right? So we're gonna figure what was the volume of the big cylinder as well. So we're gonna figure what is the volume of the smaller one, right? Which is inside. We're gonna figure what is the volume of the big one, right? Which is on the outside. I mean, yeah, the big one, the bigger one, right? Which is bigger than the smaller one. And so once we figure what is the volume of the big one, the big cylinder, and we figure out what is the volume of the small cylinder, once we figure that out, we're going to take away, we're going to take away, we're going to remove or take away this volume from the big one. All right. Again, once we figure what's the volume of both of them, we're going to take away or we're going to remove this volume, right, from this particular bigger volume. So we're going to remove the smaller volume from the bigger volume. And so what would happen? That means that the only thing that would be left would be the answer that we need. All right. All right. And so that would be that would be how we answer this question. Okay. So once we take away, right? Once we take away this volume, the volume of the smaller one, once we remove that, right, we'll be left with, right, just the volume of the roller. Okay. And that's what we wanted to figure out. And so let's do that. So the volume of the material used in making the roller is going to be equal to volume of the big cylinder minus the volume of the smaller cylinder. And so we have to figure out what is the volume of the big cylinder. So the volume of the big cylinder is pi r squared times h, and the volume of the smaller cylinder is pi r squared times h. Now, let's consider the radius. Now, the radius for this big cylinder, the bigger one, the big cylinder, we're looking at the diameter we're looking at the diameter that is 150 centimeters because we're looking at the volume of the big cylinder. So what we have 150 and that's the diameter, but we want the radius. So the radius is going to be 150 divided by 2, which is half of the diameter, and that gives us 75 centimeters. All right. So the radius of the big cylinder, the bigger one, is 75 centimeters, but we want it expressed in meters. So we take 75 centimeters divided by 100, and that gives us 0.75 meters, and that's the radius. So the radius of the big cylinder is 0.5, and that's why we have 0.5 right here as the radius. Now we need to figure out the height, and the height is going to be 1.8. All right, the height is 1.8 because if we look at the big cylinder, the height is 1.8, right? That's 1.8. Now we need to figure out what is the radius of the smaller cylinder. So we need to figure out what is the radius of the smaller cylinder. So here is the circle for the smaller cylinder, right? That's the circle for the smaller cylinder. Its diameter is not 150, right? Its diameter is not 150. This diameter is smaller than 150, right? What we have here, but we know that the whole thing is we know the whole thing is 150. So from end to end, right, is 150, right? So this whole thing, right, is 150. So from here to here, that's 150, right? The whole big one is 150, right? So from end to end, that's 150, right? Now, but we know that we have a smaller circle, and the smaller circle only has here and here, okay? And so what we have here is we have to determine, okay, what is the length of this diameter in the middle right there, right? Now, the good part about it is that we already know that this right here is 5 centimeters, right? We already know that this is 5 centimeters. And we already know that this is 5 centimeters as well, okay? So that's 5 centimeters. So if you want to figure out what is going to be the length of the part in blue, all we need to do is say 5 centimeters, add them, which gives us 10, and then subtract the 10 with 150, and whatever is left is the length of the blue part, okay? And that's what we have here, right? All we need to do is take 150, right? and subtract it because we know that this portion is 5 and this portion is 5 because the thickness around, they say the thickness is 5 centimeters. So we know that the whole thing is 150. And so we need to do is say 150 minus this 5 minus that 5. And so we'll have 150 minus 10. And so the radius is going to be, so the diameter is 150 minus 10, but the radius is going to be 150 minus 10 divided by 20. So the radius is 150 minus 10 divided by 20 because it's going to be half of the diameter. And so 150 divided by 10 is 140, and that's what this is, right? This right here, the blue part is 140, right? But we want half of 140 because we want the radius. And so the radius is going to be 140 divided by 2. And 140 divided by 2 is definitely 70 centimeters. Okay, so the radius of the smaller cylinder is 70 centimeters, but we do not want it in centimeters. We want it in meters. So we're going to say 70 centimeters divided by 100, and that gives us 0.7 meters. And so that's why here we have that the radius is 0.7. That's why we have that the radius is equal to 0.7. And that's why we have it here because the radius of the small one is 0.7 or 0.70. Okay, so now we can solve this. We know that pi is 3.14, r is 0.75, and h is 1.8. So we take 3.14 multiplied by the radius squared and multiply that by 1.8, which is the length. And we get 3.17925 meters cubed. And then we take 3.14 multiplied by 0.70 squared multiplied by 1.8, and that gives us 2.76948 meters cubed. And so in order for us to figure out what is the volume of the material used in making the ruler, the volume of the material used in making the roller, we're going to subtract. So we take the volume of the big cylinder minus the volume of the smaller cylinder. When we subtract these values, we get 0.40977 meters cube. All right. It's 0.40977 meters cube, and that's our answer. Now, I wonder if they want this into 2 decimal places. Let's see. And they said, calculate giving your answer 2 decimal places. Okay, so we have to express our answer into the 2 decimal places. And so it's going to be equal to, so this is equal to 0.41 meters cube. And the reason why that's the case is because if we look at this particular number, this is 9. 9 is greater than 5. And once you have a number greater than 5, you add 1 to 0. So 0 plus 1 is 1. So the answer is 0.41 meters cube. And that's the volume used in making that's the volume used in making the roller. And that's the answer to this particular question.